Sustainable urban drainage systems are becoming more common in the UK now due to the extreme weather situations in recent years. Extreme weather conditions in recent years have led to serious property damage from flooding, and new developments have what are called sustainable urban drainage systems factored in the design stage of the construction project. So basically, drains, rivers and other water courses were found to be unable to cope with new construction sites, and a possible means or a method to alleviate the stress that were being put on to existing water courses was to develop sustainable urban drainage systems, or SUDS, within any new project. And basically what a SUDS system does is it contains within the project areas where basically it's like a buffer that will hold a quantity of the rainwater runoff from the building site. So it could be a lake like you see here, or sort of streams built into the housing estate. So the main objectives of a SUDS system were basically to decrease the volume of water discharging or running off from the building site into the water course. So it reduces the runoff, or essentially slows it down. It can also filter and cleanse debris from the water flow, making sure that the water that goes into the drains is a cleaner water as well. So again, there's a number of reports you can get sort of from the Environment Agency, for example, the top right hand one here on sustainable drainage systems. And again, as I say, it's the provision of lakes and rivers and areas where water can build up within a construction site, but they aren't causing flooding. And generally they're put in as like a design feature, and they add a nice sort of aesthetic area to any building site or construction site. Different formats that they're available in: you can soak away, swales, infiltration basins, permeable surfaces, filter drains, retention or detention ponds, reed beds, etc. So you have a pond here, retention pond, or reed bed outside an industrial site here, again just to gather the rainwater, and it just holds it up for a period of time rather than it running straight into the drainage system. So we want to do one of the things that you need to be able to calculate then is, for when you construct a property, is to determine the rain runoff levels, or the rain runoff rates from the roof of your property. So it's important to calculate the size of the gutters and the downpipes, and these will have the size of which will depend upon the surface area to be drained. So for flat roofs, it's the plan area, whilst pitched roofs, the effective area is calculated. And we have a number of show me examples where we work through in the next number of slides to calculate the rain runoff from a typical roof within the UK. So we've seen in the show me files how you would select pipe sizes for an individual property. What we want to have a look at now is if you wanted to size the piping for let's say multiple houses. So the following method shown on this slide can be used to work out the pipework for multiple houses. So to start off, you choose a minimum gradient for all your pipes. So an acceptable gradient would tend to be in the region of 1 to 80, so 1 metre drop over 80 metre length. And you would use the table below to calculate the flow rate in each section, or a table similar to this. And the area of each surface is normally calculated from the plan drawings of the building. So an architect would be able to provide the building services engineer with detailed calculations showing the area of the parts around the building. So for example, here's an example of each house in a housing estate has the following layout. So it'll have a road or a pavement, it has a roof, it'll have a path, it'll have a garden, has an access road and parking, and then that allows you to work out the total area. So then from the tables that we were looking at, you can work out the impermeability factor, or you can extract the impermeability factors of the materials. So your road or pavement 20 metres, 0.9, 0.95, 0.75, etc. Your garden 0.25. So then you can work out the effective flow rate from the area times your permeability factor, just a simple multiplication, and then you get your total runoff rate on the right hand side here, which is 103.5. So basically when you work your way through those calculations, you can work it out for the UK rainfall factor as well. So basically this is just an elaboration on the previous slide where we're bringing in the UK rainfall factor R, which is 50 millimeters per hour. So again, same calculation, but this time you just multiply 1, 2, 3 all together, and it gives you your total runoff rate of 1.49 litres per second, and that'll give you the runoff for each house, and then you just basically multiply that by the number of houses that there are in the housing estate. So if each house gives you 1.49, 12 houses at 1.49 gives you 17.88 litres per second from all 12 houses. And then again you use the same pipe sizing graph to estimate the size of the drainage that will service all 12 houses. So again, when we look at the bottom here, 1 in 80 is the drop off or the fall off rate of our drainage system, and basically we said 17.88 litres per second brings us in around about there. So for surface water we could again use a 150 millimeter diameter drainage pipe that would in fact service all 12 of those houses. And finally, just to conclude, all drains must be tested before and after backfilling of the trenches. There's two types of tests that you can carry out on drainage. You can do a water or air testing, and BS 8005 gives the details of acceptable water and air tests. And in addition, you can also do, or alternatively do, a smoke test. And a smoke test is undertaken by sealing the drain and basically pumping smoke into the pipes from the lower end. And then you basically just check the pipes, inspect the pipe run for any traces of smoke, which would be an indicative of a leak. The air test, as I said, BS 8005 give details of the air test, and basically the drain is sealed between the access chambers and is pressure tested with the hand bellows and a U manometer gauge. So basically that's what this guy's doing here. This is your U manometer gauge to do an air test. You basically build up the air pressure initially to about 100 millimeters in your water gauge, and then after 5 minutes adjust the air pressure to 100 millimeters in your water gauge. Pressure mustn't fall below 75 millimeters during the first 5 minutes, and basically that's a drop of pressure of 25 millimeters over 5 minutes. So that's the test that's outlined in BS 8005. Your smoke test, the length of drain to be tested is sealed, and smoke is pumped into the pipes from the lower end. The pipes are then inspected for any trace of smoke along the length of the pipe run. Smoke pellets may be used in a smoke machine, or with clay and concrete pipes they can be applied directly to the pipeline. And basically that concludes the second section on underground drainage.